Hi, in this video we are going to discuss sinusoidal steady state analysis. When AC circuits is present in our problem, so we have to follow the following step. Step 1, transform the circuit to the phasor or frequency domain. The given values are in time domain. We have to convert first time domain things into frequency domain. After that, we have to solve our problem using various techniques. It may be a nodal analysis, mesh analysis, superposition theorem, or any other theorems. Finally, the result should be again converted from phasor quantity to time domain analysis, time domain quantity. So these three steps need to be memorized for solving any problem in AC circuits. The first thing is we have to convert the given time domain parameters into frequency domain parameters. Then we have to apply suitable techniques. Finally, the result should be again converted from phasor domain to time domain. The first problem using nodal analysis, we have to find this Ix. We have to find this Ix. So when we compare DC and AC, in the AC circuits, what are the changes or new things are? First one is source. So in DC we have only 20 volt or 10 amps like that. Whereas in AC we have some phasor quantities also. So 20 cos 4t. Again next we have capacitance as well as inductance in addition to resistance. So when we compare DC and AC, these are the changes, these are the various parameters included. And also we have in this problem we have one dependent source. So 2x, actually Ix is current through this capacitor. So the first step is we have to convert the time domain into frequency domain. So our phasor domain. So first we have to convert this source. So this is time domain. We have to convert into frequency domain. That is magnitude at an angle phi. So in this one, 20 is the magnitude. Angle is 40 plus 0. Actually plus phi. Phi is 0. So 20 at an angle 0. So here the capacitance and inductance are given in farad and Henry respectively. So in order to convert time domain into frequency domain, actually phasor domain, this should be, we have to use this j omega L. This formula we have to use. For us capacitance, we have to use j omega C. J omega C. So once you follow these things, we can convert all these elements. So source, 2 inductance and 1 capacitance. So once you do this, you will get these values. So here omega is, and that is 20 cos omega t. So omega here 4. So 4 radian per seconds. Okay, once you convert everything, you have to first apply all these things in this circuit, then you have to modify the given circuit into frequency domain or phasor domain. So the modified circuits here, everything that is in terms of Henry or in terms of farad, everything will be converted into ohm, that is j omega L. So j omega L is nothing but XL, j omega C is nothing but XC. So all these are all in ohms. So you have to convert everything into ohms. Here source is 20 at an angle 0 degree. Okay. So once you convert this everything and modify the circuit, then you can apply the nodal analysis. So the nodal analysis here, actually we have a voltage source. If voltage source is present, then we have to use either super node analysis or a simple method. There are two cases. Actually this voltage source is connected across one non-reference node and reference node. Actually, the nodes are here. This is one node 1, this is node 2, this is a reference node. So this voltage source is connected across node 1 and reference node. So we can solve this problem without using supernode. If a source, this voltage source is connected across node 1 and 2, then we have to use supernode. Okay. So there are two non-reference node. We have to formulate two equations with respect to these two nodes. So when we do the first, according to at first node, or node 1, here we indicate the current direction arbitrarily. So suppose this is I1, this is I2, this is I3, then at node 1, I1 is equal to I2 plus Ix. So you have to use a formula with respect to voltage, nodal voltage. This is I1. So I1 is nothing but 20 minus V1 divided by 10 is equal to I2 is V1 minus V2 divided by J4 plus Ix is V1 by minus J 2.5. Then you have to simplify this equation. So suppose J4 is there. So 1 by J4 is 1 by 4 is actually 1 divided by 4 is 0.25. So J4 is 1 by J is minus J. So 0.25 minus J 0.25 into V1 minus V2. Then 2.5, 1 by 2.5, 0.4. So minus J is there. So it will be converted into plus J 0.4 V1. Okay. Now 20 minus V1 is equal to 10 of this. So once you simplify this one, you will get this equation. Similarly, for node 2, you have to write another equation. So node 2, here I2 is entering, 2 Ix is also entering the node, I3 is away from the node. So I2 plus 2 Ix is equal to I3. So you have to write the formula I2 P1 minus V2 divided by J4 Ix. So I3 is V3 by J2, V3 by J2. Ix is nothing but, actually Ix is here we have. So it is given Ix is V1 by minus J 2.5. This should be substituted here and simplify this. You will get the second equation, that is 11 V1 plus 15 V2. Okay. So once you get these two equations, these two should be again modified as a matrix format. So this is the matrix format for these two equations. Since it involves complex number, that is imaginary parts, so we cannot directly take solve using computer this equations V1 and V2. So you have to take a delta, that is modulus of this equation and this matrix, that is 15 minus J5. Then del 1 is nothing but by replacing the 20 0 into the first column. So 20 0 J 2.5 15, that is 300. Then del 2 you have to replace the second column. After that you will convert V1, you can find V1 V2. So solve using calculator one by one. So our question is we have to find Ix. So Ix is nothing but that one we derived v1 by minus j 2.5. So v1 can be taken from this, then minus j 2.5. So in calculator you can use at phasor, then we can use a combination of phasor as well as rectangular form. Okay, so proper bracket should be used. So once you convert into phasor form this ix, you will convert into a time domain. Time domain, this is phase magnitude, this is phase angle. So 7.59 cos 4t plus 108.4. Okay, this is the answer. This is without using super node. In this circuit actually we have a voltage source across non-reference node V1 V2, that is 10 at an angle 45 degree. So we have to use super node. Before that you have to convert everything. So sources are given already in the phasor form, so and also the capacitance inductance values are also given in the phasor form. So no need to convert everything. We have to apply directly super node, nodal analysis with super node. Okay, so when we apply super node here, we have to use a KCL for writing the equations. So this is 3A, incoming current, outgoing current, outgoing current, outgoing current. So 3A is incoming, remaining are outgoing. V1 by minus J3 plus V2 by J6 plus V2 by 12. So instead of taking LCM, you can directly take the inverse of this one, that is 1 by minus J3. So 1 by 3 is 0.33, 1 by J is minus J, again we have 1 minus, so plus J. So J 0.33 V1 plus here 1 by 6. 1 by 6 is 0.166. So 1 by J is again minus J. So this should be minus J 0.166 V2, then 1 by 12. 1 by 12 0.0833. So this is a real term. So 0.0833 V2. Okay. So this is 3. Then you can simplify this V and V. Okay. So using this you can formulate one equation. Here you have. So here they take LCM and write this equation, but in our case we will not get this type of equation, we will get another equation, but the procedure is same. Okay, the next thing is we have to apply voltage, KVL. Here in the across the super node we have 10 at an angle 45 degree voltage source. So what we can write is V1 minus V2 is equal to 10 at an angle 45 degree. 45 degree. So V1 is equal to V2 plus 10 at an angle 45 degree. So you can substitute V1 here in this one. So you will get only V2. So once you simplify this equation, you will get V2. Once you get V2, you can substitute this V2 here, you will get V1. Okay. So this is V1, that equation. Once you substitute this one, you will get V2, 31.441 at an angle minus 87.18. Then again substitute V2 here, you will get V1. So you can find V1, V2. The question is compute V1, V2. Then you can convert this into frequency domain. Okay, into time domain. So these are the